Hey guys, this is Eric Weingartner with Weingartner Racing with another video about this LS3 Flowtech head, which is the internet ports heads. I've tried a lot of different things on this head and I want to share them with you. Now, some of you might be saying, oh, another LS head. Does he ever do anything besides like LS and Chevy stuff? It's really whatever comes in the door, but this is just a project that was taken on way back. And if you look at my other videos on my channel, which I encourage you to do, you'll see I've done several different heads. The ones you probably won't find is anything import stuff. And the reason why is because I really don't import stuff. Part of the reason is I don't have any flow fixtures. And the other thing is I'm so busy with domestic stuff where I take on extra import stuff that I don't have a good enough knowledge base on. So I'm with the domestic 2-valve per cylinder stuff. Anyway, so here we have the LS3 head. This video, I actually did a bunch of stuff, stayed up some late nights working on this thing. And this is right here is the port that we're going to be talking about. And I'm going to tell you about all the stuff I've tested with it. And some of it might be a little strange to you, but I just want to get it through in the first early bits. So to start off with, what you're seeing is where the ends. You'll get to see through the video some of the beginning phases. This port was the one that was dimpled. I had done that dimpled video. It's got probably the video I have with the most views and most comments. But anyway, I took that one and several people asked me, hey, could you just port it like you normally would? So that's what I did. But I kept the same stock valve job. Didn't change it, just kept that stock one there. Ported that first. Then I put on a different valve job, mine, and didn't do any blending to see what happens. Then I did a 90% throat, or sorry, 91% throat. So I tested 90% throat, 91% throat. I even cut down the guide to see if that helped flow. I tested 3 different intake valves to see if that affected flow. I did the chamber work to see if this affected flow. And also, which I didn't say the results on this, I tested 2 different spark plugs to see if that had anything to do with flow. And hopefully, as I'm recording this, I thought of something else I wanted to test and didn't get a chance to, but I hopefully will get to it. If not, it'll be on the next video. But anyway, let's get started. For those who are new to the channel, this is an LS3 Flowtech head. It's pretty basic. Usually whenever I do these heads, when I'm porting them, it's specific to an engine, but obviously these will never go on an engine. It's just for fun. So the bowl ended up a little bit larger than I normally would have made it for most stuff, and I'm going to tell you why. It's actually bigger than even that bowl, which is 100%. The reason why is because this head, I'm telling you in case you ever get one, right here, they leave a bulge here, so it makes it look weird. So it comes this way and whoop. It's thick enough there where you really don't need that. So I got rid of that bulge. Well, that of course makes the bowl wider than what it should be, but I don't like that. I wanted a nice contour like it should be. I wasn't necessarily trying to make it bigger over here. I just wanted it where it should be nice like this, instead of coming up over a lump and then back this way. Of course, I brought out the wall on this side too. The bowl ends up at 100, and I think if I remember right from measurements, 103%, which is not overly large, but it's not 100%. Usually I've tried it. For most LS stuff, because they're only turning like 64 to 6,800 RPM, not all customers, but the ones I get for this stuff, because they're hydraulic roller stuff, just a street type deal, street step, that's about the RPM. So usually in that case, I'm about 100% on the bowl. This one's of course bigger. I tried 90% throat, and as far as the rest of the port-wise stuff, it's all the normal stuff I would do. So because of that, I'm going to flip this head around so you can see. You can tell that the dimples are still in the port because I don't really take out a whole lot of meat from this area anyway, because that's not where it needs to be taken out. This is already from the factory kind of big, bigger than what it should be. So the dimples were there for all the tests in this area, just not because they're targeted to be that way. It's because we'd already had them there to start off with. So if we look down on the port, this wall just gets blended in, didn't move it over. I did not take out this lump here because if it was a head that came in, I would leave this lump here. And you're like, that looks horrible. The reason why is because that's where the spring pocket is. And from doing the other ports, I could tell you, you will break through. There's no question. So just to let you know, that's why that lump's there. Move the wall out on this side, and you can see the short side, how it's done. Let me get a better view of this side. There you go. Rounded off the short side some, and didn't really lay it back much, because I will say, if you ever get to porting these Flowtech LS3 heads have actually a short short side. So if, in other words, if I look at the distance from the apex, which would be the peak here at the short side, to the deck, it's actually shorter than the LS3 stock head. It's shorter than several of the other ones I've seen as well that are aftermarket. So you need some short side height when you have a reduced valve angle, which this is. And by the way, these are 15 degree. So typically on any, you can think of it like when you make the angle on the valve shallower, like 12, 9, so on and so forth, because it's tilting the valve this way, the short side needs to come up. So taking off the short side height's not a good idea, which we already know anyway from the, I think it's this one, the 50 degree. So that's how it is. And I'm gonna show you the results from flowing it. Now, I'll go ahead and warn you, I floated on both bores, but primarily on just one bore. All right, let's look at the numbers. Okay, here are the numbers, and we'll get to some information about this. These numbers are from the Sanyez flow bench, and I floated on a 4030 bore. Now, several people have said, well, the stock LS3 or 6 liter is a 4.065 bore. Why did you float on a 4030 bore? It's because that's what I have. I have a 4030 and I have a 4155. I don't have a 4065. And I know several people said you should float on that. I should, but that fixture setup is about, it's 400 for the plate and 200 for the bore, actually higher, 300 for the bore, so 700 bucks. And generally, going from a 4030 to 4065, that's really only about 15 thousandths on each side, the cylinder, so it shouldn't make that much difference. But if you watch my last video, you're like, evidently it does. And I know some of you watched my last video and you thought I was talking about the bore size, but I was talking about the chamber size. So I'll show you what I mean before I show you the numbers. So here's my Flowtech head, and I wanted to show you this. So this is my dial calipers. This is what I was telling you. If I take my dial calipers and I go across, if I could try. All right. If you notice, it's 4083, and I'm probably hitting the wrong spot still at the top. It'd be higher. Yeah, 4095. Okay, remember, stock bore is 4065. That's what I mean by the chamber's wider. This is a stock LS3 head, which, by the way, in case you're wondering, why is it here? They wanted to rebuild, but look, in case for those that have the stock LS3 heads, yeah, they crack. There, 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 there. Now, regardless though, let's look at its bore. Its chamber size here, not the bore. 4061. You get what I'm saying? This one, this chamber width is smaller than this. So just keep that in mind. So when I was finding the problems when I was doing, I think it was, they're backwards. When I was doing the 50 degree port, the reason why the bigger bore made such a big difference is because this chamber is wider than the stock one. So if I'd done the same port on this, it probably wouldn't have had as much influence because of this. Okay. Anyway, let's get to the numbers. This is where we left off. This was stock just dimpled. That's exactly where it left off. This is it ported on a 4030 bore Sanyez. If we look, ignore the 100, which I should tell you. 200 is a pretty good gain. Gain, a bigger gain, much bigger gain at 7, gain. Now, most of you are like, wow, you didn't really gain that much down low. Yeah, but I'm telling you now, it's going to make more power. The port itself is better designed. It's going to be better. Plus, the way it stays stable and stuff, it's pretty good. It's pretty good for what it is. It should make more power anyway, even though it doesn't look like it's going to, because it doesn't look like, if I ran a 600 lift cam, it would look like I gained 7 CFM for all that work. Yeah, remember, there's no chamber work in this either. Yeah, but it's going to make a difference. I would put money on it. But after this, I said, you know what? I don't want the chamber to influence anything what we're doing as far as the changes. So after that, I started flowing on a 4155 bore on the Superflow. And why the Superflow? Because the bore sleeve was already set up on that bench. So I just started using that one to do all the tests. So from here out, it's on a 4155 bore, float on the Superflow. Let's look at those numbers. Okay, this is bench to bench, so there's a little bit of difference, but this gives us a new baseline. So there's nothing done with the head. It would just float on a 4155 bore on the Superflow. These are the numbers. Ignore one. Gain, lost there. Huge gain at 4. Gain. You get the idea. So in the end, it's flowing 371 at peak. At 600, it's 348. I do want to say my printer is turned into a piece of junk. If you guys happen to recommend a printer that doesn't cost a fortune in ink cartridges, that also doesn't cost a fortune, please put it in the comments. I had a great one, and then they stopped making it, COVID. But anyway, so now I have this Canon, and it was good, it's not anymore. So that's why. So here's our baseline. There it is, ported with a 90% throat. From here, changes are coming. So let's get to it. Next thing should be the valve job. Okay, ignore the sound in the background, that's the servicer running. But I wanted to show you this before I go on so I can get on with it. If you watched my last video, you saw me talk about the bore size and stuff. This is the port that I ported that was stock. The only thing I've done from here is I cut down the guide. So the guide was long, like that. See how tall it sticks up? And I had done it before with this port if you watch like the earliest videos. Well, I wanted to see if the same trim would apply if I did it again. So I cut back down the guide about 200 thousandths and reflowed it. I'll show you those numbers in the end, but I'll go ahead and tell you it made it worse. So doing that, even though it sounds totally ridiculous, going from that, which is a heck of a stick up, to that, it lost flow. Not a lot, like 2 CFM, but I wanted to show you that. Now I'm gonna go ahead and put my own valve job on and open up the throat. Here's what I said I was gonna do the valve job first. Instead, I cut down the guide first. So this is their start. This is just cutting down the guide, which is kind of shocking. It actually didn't help it at all. So cutting down the guide, and it's about 200 thousandths got removed. Loss, 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 loss. Well, you get the idea. It lost everywhere. To me, it was kind of shocking because I figured, hey, that guide being in the way, it's got to be a restriction that's got to hurt it. It just didn't. It didn't at all. So there's that. All right, next thing is the valve job itself, no blending. Okay, so I had a wild thought, so I'm gonna go ahead and do this. I went ahead and put my own valve job on it. I'm gonna show you, this is the port. So I went ahead and put my own valve job on it. Now, this valve job, in case you're wondering, it's a 45-degree valve job. For those who haven't watched the other videos, I'll go through this real quick. This one's a 50-degree valve job. I use it on most of my race stuff. I talk fast because I'm trying to make things go quicker so you don't have to keep fast forwarding through the video. This is a 50-degree valve job. I use it on most of my race stuff. This was a 45 that the people had picked, which was my most aggressive 45. I use it whenever people can't use a 50 because they want more longevity, but it's still pretty aggressive. This one's a 55-degree, which is really aggressive, and it's typically only used like on big block stuff or things that have a lot of lift, as in more than 800. This one is my 45-degree valve job that I put on all the profiler stuff. It's good for street and race. Typically, a customer comes in and brings in a head and says they're going to do more street use with the head than they are a race. This is typically the valve job that will go in it if it's meant for the head. So there's different, I have different 45s otherwise too that have different top cuts and such. But for most heads in general, this is the one. It's not made for everyone for sure. So like on a street deal that the guy races, it's this one. I've got less aggressive ones too. Just wanted to show you that. But here's what's gonna happen. I haven't blended it at all. So what you see is exactly how it came off the machine. So what I'm gonna do is I'm gonna flow it because it's still at 90% throat. I'm just gonna flow it and see what it changes. Then I'm gonna go 91% and we'll see what happens. All right, on the bench I go. Here are the numbers from the valve job versus what we had before. So here we were before. This is just the valve job, not blended. Let's start from this point on. I've left off the 100 number because it was one quicker and two, the valve was being sucked open at this point anyway, so those numbers aren't accurate. From 200 on they are. So if you look, loss, gain, loss, loss, gain, loss, gain, about the same, and gain. So for the most part, this was a loss just doing it like this. But the next thing we're gonna try is blending in the valve job, which you're gonna see that numbers. Okay, now I've blended in the valve job. As you could tell, it's still burred like I usually do around the valve job. It is now 91%, and I'm gonna flow it and see what's happened. Here's what it's like after blending in the valve job. So from here to here, about the same, worse, worse. Gain, that's a good gain there. Better, better, a lot better there and there. Which I know some of you are like, yeah, it doesn't look like you gained anything. I mean, the only part you gained where no one would have. Again, it tells you how stable the port is. But regardless, at 600 valve lift, you look, you're now at 353 CFM compared to where we started this whole process. Just being ported with the other one was 348. But it's still a pretty good gain. It's a loss here at 5 though, so that's kind of worrisome. But at this point, well, you'll see. Okay, guys, I'm recording this because I'm probably getting ready to mess up the head. But I'm going to show you what I did. I did the throat at 91%, which I showed just a second ago. Hopefully, if the video has been edited right. But I wasn't too happy with the results. Looks like I kind of lost in some areas, which I didn't think would happen. But I wanted to try something that I tried before on a small block Chevy stuff because I did a ton of, and it never worked. Other people would claim that this was the ticket and it would make things better, and it didn't work. But I wanted to revisit it, and I did here. So I'm going to show you what it is. This is the short side, and these are the angles here for the short side. All I did was, it's still 91% throat, which is across here. This was also, it's actually slightly undersized, like 90.5, because I left more of the radiuses for the air to make the turn. But several people I've talked to have said to flatten that out. And I'm always hesitant to it because I know you can't see it, and I'm not going to tell you what I do with my throats. But if you look at it, hopefully it'll give it away what it's been done. But anyway, I took more off right here. That's all I did. And still made it curve, of course, not just flat into it where there's sharp edges. And it looks that way because it's got the burr finish, but not really. So I took more off here and reflowed it. And I'm talking very little. So it's still this 91% still that way and 91% this way. You wouldn't have thought it taking off as little as I did made such a big impact, but it does. I'll show you the results at the end, but I wanted to record this before I do any other changes because otherwise you'd be like, I don't get to see what happened because I'm getting ready to do some other stuff which may hurt it, and this might be the best that this port's ever going to be. But yeah, I just wanted to record it just so I could document it for you guys. All right, off to the next thing. This one's a bit more interesting. That little bit of work just on the short side in that one area near the throat changed things pretty dramatically. I mean, for the small amount as it did. Because if you look, about the same. Gain, gain, gain. About the same though. The gain, there you go. Jumped up. That's a great gain right there. Good one there at 7. Gain, gain, and gain. So just doing that little thing, that one picked up everywhere. So not bad. Although you'll keep looking at it like, man, you're killing that 400 number. But it's starting to come back a little bit. At this point, though, I was like, you know what? It's time to do some chamber work. So I'm going to show you what I did on the chamber so you can see. I rounded off the spark plug, which you can kind of tell. And then there's a bump right here. You see him on this? Got rid of that. And then I took off this edge here because several people said, why don't you take that off? That's got to kill flow. And I do plan to do this one here for you guys just to see what it gains on flow. But I want to stop there for a second. There are several things you can do like this that will help flow, but will make less power because these sharp edges, when the fuel comes off, it kind of stays there. And then the airspeed will cause it to reatomize. So this is better for wet flow, having a somewhat of a sharp edge somewheres. Now, obviously, you don't want it here more on the exhaust side because that's where you can have detonation. That's why usually when we soften, we're on this side. So just letting you know. But the wet flow, they want that edge there. So you could take it out probably, and it's probably going to gain some CFM, but it doesn't help on the wet flow side. But regardless, I did it on this whole bottom. And I thought, man, this is going to make a difference. Let's see. This is number 7 or 6. Boom. Gain there. That's a huge gain there for that number at 2. Gain, about the same. A little bit of a gain, about the same. Worse, 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 worse. That's right. All that chamber work just made it worse. So,
By the way, this is a cross buff because I want to make it nice and shiny because you guys, some of you like the super smooth finish. So that's what I give it. Usually it's like at the most I'll do an 80 grit. I rarely ever do a cross buff on here because it looks beautiful, but I like a little texture. On some of the heavier nitrous stuffs and turbo stuffs I will, just because it, to keep the detonation out. Because there's a difference between like, wet flow is good and all, but you still don't want it to melt down your engine because of detonation or something. So we try to take those out. It's more important at those points. But anyway, in a different story. So yeah, not a win there. Kind of a letdown. This point I started changing different valves though. So I'm going to show you some of the valves and how they changed. So doing quite a few valves here and you get to see them all different. For these next three tests, they're just testing different valves. And you'll see how much you could change with just a valve. So this first one's, which is number 6, that was chamber work. That's this one. This is a Freya. And you can tell what it is. It's a 45-degree seat, obviously, because that's what the valve job is. And it's a 33-degree back cut. And it's kind of wide. Okay? That's what I had. That's what I've been using for all this. And then I switched to this. It's a different Freya. Except for this one, instead of doing a 33-degree back cut, I did a 30. And also not as wide, just to kind of see what it do. If you look at the difference, just from the valve itself, loss, about the same. I should say about the same, about the same, about the same, about the same. Loss, 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 loss. So, yeah, you wouldn't think just a little angle there on the valve would have so much of a difference, but it definitely did at the high peak stuff, which is kind of weird. Usually the back cut does a bigger difference on the lower lifts. Anyway, I had one more valve to try. This is from a stock LS3 valve, which when I first flowed the heads at the very beginning, I actually flowed them with this. You can find these in your stock LS3 heads. Very common. I think they've got a 30-degree back cut on them, I'm going to say, because it's typically what they do, and it's really wide. Also, there's not much margin on this. Margin being the area here. That's just how they come, which I hate. I'm sure it helps with the shear of the fuel, but most of the aftermarket ones have more material, so that for rebuilds it's easier, one, because I can reface them, and two, it feels like they're stronger. Of course, there's the downside, they weigh more. Let's look how they flow. You look at that one, you can compare either of these. It was worse. It's actually worse. Slightly better at 4. Best there. The best there. A lot worse. Worse. Now it's getting better. Now it's better than the other ones. And then at the peak, it's better than those two. So that's kind of where we wrap up things for this. 379 CFM. That's kind of where it's at. Now, I did try, and I'm going to show you real quick so you can get an idea what I'm talking about. Because I did try something, but I ran out of room on here. Otherwise, I'd printed it off. But I tried one other thing, and it's kind of disappointing because it made no difference. But let me show you real quick. I tried this. Here are 2 different spark plugs. All right, you can ignore the heat range. That's not really important for the flow part. This is a projected tip spark plug. See how the tip's projected out past it? Okay. These are most stock spark plugs are like this that come in the LS. They have a projected tip. However, I also want to flow it against a non-projected tip. Most nitrous engines are used at something like this, and power adder for that matter, like turbos and superchargers. The reason why is because typically the heat is more in these, and they just cause issues with detonation, usually for the power adder stuff. But some people still use them for them. Anyway, why did it make a difference? That little stick out, it's weird. I'll go to my small block Chevys for this because I have more experience on both ends on this. I say my Dragon Slayers with small block Chevy head, if I put this spark plug in and I change it with this one flows better. I know it's weird. It's like 3 CFM better. But the catch is on the dyno, because I've done it with my Dragon Slayers, I tried running this thinking it would should make more power because it flowed a little bit more air. Same heat range and everything. For whatever reason, the projected made more power. It could be where it puts a spark, but something to think about. But I was curious on the flow bench on these LS heads, and it made 0 difference. I mean, you could have overridden them. They were off by maybe 1 CFM, so it wasn't worth it. Now, there's one thing I didn't get a chance to test because I just ran out of time. It's this. And this one's going to sound a bit odd, so bear with me as I try to describe it. So if I take my LS head, and I have a valve in here. So far, every single one of the tests have been on the exhaust side. I've been using this valve in its place. This is a stock LS3 valve, nothing fancy. Doesn't have a radius on the end at all. And this is what I've been flowing with. Okay? Which you're like, I don't get it. Well, as the air leaves this, it does have to go over, a part of it has to go over that exhaust valve, right? Well, this is a Frey exhaust valve, which we talked about before. This is a tulip design. If you notice, it has a radius or rounded edge for its margin. I think they do this to help reduce the heat, so it's less likely to detonate, but it does have another added effect. The air can flow over that corner if it was here, easier on this than that. This should make somewhat of a difference. I didn't show you the final flow numbers on those Dart B mod heads, but what's weird is having the radius here help the intake flow. So in a class that doesn't have any porting, that you're not allowed to port, little stuff like this can make a difference because that head's already restricted. I didn't get a chance to test it on this, but I may later. So I want to give you that. Anyway, that's the video. Thanks for sticking around for such a longer one. I want to make sure I get everything covered. I still got more stuff to play with it on, so look forward to that video. I do want to leave you with a little bit of advice. When I was teaching, there's these things called paroxysms. It's like a phrase that has a weird twist at the end. I'll give you a quick example before I give you the good one. You ever heard this phrase, the last thing I want to do is hurt you? Yeah. Well, there's a paroxysm where there's a twist to it. The last thing I want to do is hurt you, but it's still on my list type of thing. That's a paroxysm. But anyway, I want to leave you with this one. Never argue with an idiot. They'll drag you down to their level and beat you with experience. So I wasted part of my day today with one of that problems. So anyway, you guys, thanks for watching and take care.